Imagine for a second looking up at a towering city skyscraper and realizing it's not just concrete and glass, but a massive, hyper-efficient agricultural engine. Welcome to this explainer. Today, we're exploring exactly how vertical farming is completely transforming static architecture into living, breathing, and completely self-sustaining ecosystems. To really grasp this, we have to start with a pretty critical question. As urbanization absolutely explodes around the globe and fresh water rapidly depletes, how on earth do we feed growing cities without expanding our horizontal farmland? Urban planners are losing sleep over this. We simply don't have the space to keep sprawling outwards. Well, the solution is a massive paradigm shift. Instead of horizontal spread, we're looking at volumetric density. Basically, we grow up, not out. By utilizing vertically stacked indoor environments right inside our skyscrapers, we can actually multiply yields up to 100 times more per square meter than a traditional flat farm. It's honestly incredible. So, in this explainer, we're going to cover the urban farming paradigm, dive into soilless nutrient delivery, look at skyscraper integration, break down the economics, check out some mind-blowing real-world designs, and wrap up with the future of urban living. Okay, part one, the urban farming paradigm, which is really born out of necessity and crisis. To put the stakes into perspective, the World Health Organization notes that a staggering 55 million people face the devastating consequences of drought every single year. So for urban planners and architects today, baking extreme water conservation and drought resilience into building designs isn't just some eco-friendly trend, it is an absolute, non-negotiable necessity for our survival. Moving on to part two, soilless nutrient delivery systems. Let's be real, you can't exactly haul thousands of tons of heavy, wet dirt up an elevator shaft. Instead, we have to engineer a lighter, smarter way to feed these plants at the root level using soilless science. You've got hydroponics, like the nutrient film technique, where roots basically just chill in a continuous shallow stream of water. Or you've got aeroponics, which takes a different route. It suspends the roots in a dark, enclosed chamber and periodically blasts them with a pressurized nutrient mist. And here is where the resource efficiency gets really impressive. Hydroponics alone slashes water use by up to 90% and fertilizer by 60% compared to traditional soil. But aeroponics, it goes even further. Because it uses pressurized misting, aeroponics generates an even greater water use efficiency, literally more crop per drop. And you can boost that even more by increasing the nozzle arrays to maximize oxygen around the suspended roots. Now, what do we actually grow in these highly controlled, dense structures? If you're planning one of these facilities, you have to look at the economics. Cultivars like leafy greens, microgreens, herbs, and tomatoes are absolute rock stars here. Why? Because they have super short growth cycles and a high harvest index, meaning you can eat almost the entire plant. Plus, they sell for a premium. This is absolutely crucial advice for maximizing profit in urban setups. All right, part three, integrating farms directly into skyscrapers to build synergies. Standalone vertical farms can sometimes struggle with huge energy bills, but when you integrate them into a high-rise, it's a game changer. It creates a closed-loop circular ecosystem. First, the building's waste heat is captured and used to warm the farm. Second, the moisture the plants sweat out, transpiration, is harvested as gray water for the building's toilets. Talk about maximizing water reuse. And third, the organic plant waste is composted to generate methane electricity, which then powers the LED grow lights. In the planning world, this is known as the Wi-Fi nexus, synthesizing water, energy, food, and the environment into one continuous, unbreakable loop. By embedding the farm directly into the commercial framework of a skyscraper, the building itself becomes a living machine. It feeds the people working inside it while flawlessly managing its own waste and energy. Which leads us perfectly into part four, the economics. Is this actually financially viable? While back in 2020, the global vertical farming market was already valued at $3.24 billion. That is a massive indicator of market confidence, folks. Investors and developers are clearly seeing the immense financial potential of moving food production right into the heart of the urban core. Yes, the initial infrastructure costs are high, there's no denying that. But the long-term profitability drivers are wild. These systems use 95 to 98% less water overall. Just look at the Bustanica farm in Dubai. They are saving a jaw-dropping 250 million liters of water every single year. Add in the fact that you get year-round production with literally zero crop failures from bad weather, plus advanced systems cutting energy usage by over 50%, the math really starts to work in your favor. Okay, part 5. Let's look at some real-world vertical farm designs that are pulling this off today. Check out Pierre Sartre's concept, the living tower. You've got wind turbines crowning the exterior to capture renewable energy, while vertical culture circuits are woven right into the core of the building. It perfectly showcases how volumetric density can be functional, green, and architecturally stunning all at once. Over in Shenzhen, China, architect Carlo Ratti designed an absolute marvel, a true farm scraper. It literally grows food on its exterior walls using a robotic hydroponic facade, all managed by an AI-supported virtual agronomist. It's producing a staggering 270 tons of food per year. Just an incredible use of space. And in Vietnam, Votron Nia Architects built an urban forming office where exterior planters on a steel frame act like a natural air conditioner. They filter the harsh sunlight, creating a cool, shaded microclimate for the workers inside. It achieves a 190% green ratio compared to the actual land footprint, yielding over a ton of harvests literally outside the office windows. Then there's Oliver Foster's Type O design. This is a brilliant multi-purpose approach that seamlessly stacks hydroponics, restaurants, residential apartments, and fish farming. It creates an aquaponic loop where the nutrient-rich water from the fish actually feeds the plants. It's a fully integrated food web inside a building. Finally, part 6, how all of this reshapes the future of urban living. The true future relies on mixed-use integration on a massive scale. We're talking about fusing residential, commercial, and institutional spaces into giant self-sustaining biospheres. Take Stefano Boeri's 110,000 square meter complex planned for Shanghai. By combining everyday office and living spaces with vertical farms, these structures don't just grow food, they generate localized income, create high-tech agricultural jobs, and foster genuinely sustainable urban living all in one single footprint. Architect Carlo Ratti really hit the nail on the head when he said, large vertical facades allow scaling up in a way that can really help cities, the biggest consumers of food produce, to become more self-sufficient. That word scale is everything. We have to move past small neighborhood community gardens and start building these monumental architectural integrations if we want our cities to survive. So I'm going to leave you with this final thought to ponder as we wrap up this explainer. As our static concrete architecture slowly evolves into these living, breathing, water recycling farms, how will your city skyline feed you tomorrow? It's a wild thought, right? Thanks for joining me on this one, and keep looking up.